Okay, let's look at another example. The feral pigeons in a city environment are studied over a period and the following data is collected. So we have age, population, birth rate, death rate. We need to create a Leslie matrix and find the population after 1, 2, 3, 4, 5, and 10 years. Find the approximate percentage increase in the population each year, an estimated overall growth rate, and suggest a culling factor to gradually reduce the number of pigeons. Now, that's the main part of this example. So, first of all, we need the Leslie matrix. It's given us death rate and we need survival rate. And that's going to equal 1 minus the death rate, which makes sense. So 0.4, 0.5, 0.3, and 0. So our Leslie matrix, we're going to have our birth rate across the top, and our survival rates on that diagonal. And everything else is 0. Our initial population matrix. Now, to do the population after 1, 2, 3, 4, 5, and 10 years, for 1 year, it's going to be equal to your Leslie matrix times by your initial. Go to your calculators and you get, for 2 years, that's going to be L squared times by initial population. And you get 3 years, L cubed times your initial population. And I'm just going to finish off the rest because I think you've got the right idea. So to work out the percentage increase, we need the population at the end of each period. So initially 3950, 5615, go through and work those out. And then your percentage increase is going to be your current population divided by your previous population. So 5615 divided by 3950, you get approximately 1.4215, which is approximately 42.2%. So go through and work all those out. Now for that 10 years, I had to go and actually work out the population at 9 years, which was a little frustrating. But what have we done? We found the population at the end of each year. We found the percentage increase in the population each year, an estimated overall growth rate. So that's our eigenvalue. So we want our eigenvalue of L. So go to our calculators, and our dominant positive eigenvalue is approximately 1.28515, which gives us approximately 28.52%. Now, the next part is to suggest a culling factor to gradually reduce the number of pigeons. Now, to be able to do that, we're going to use our eigenvalue. So from our eigenvalue, we know that our population at any point is going to be 1.285 times by the population of the year before. and that's for large N's. To choose a culling factor to keep the population stable, we're going to use the fact that so we have P of N equals 1.285 times P of the N minus 1. Now, for a culling factor, we'll call it H, we're going to use the fact that our population at any time is equal to our Leslie matrix times by the population of the year before. Okay, so L prime is going to be 1 minus H times by our Leslie matrix. That means that our population at any point is going to be our L prime times by our population of the year before, which is going to be 1 minus H times by L times by our population of the year before. And then using what we just found, that's going to be 1 minus H times by 1.285 P to the N minus 1. So that's there. Okay, realizing that this here is equal to P of N. So therefore, for a stable population, we need 1.285 times 1 minus H to be equal to 1. So that means 1 minus H is equal to 1 over 1.285, and H is equal to 1 minus 1 over 1.285, which is 0.222. So therefore, since we want to reduce the population, the culling factor should be more than 22.2%. So you might choose a culling factor of 25% or more. Because you don't want to maintain the population, you want to actually reduce it.